Hi everyone, so now we're going to learn how to use our trigonometric functions to solve for real-world problems. These are typically problems where you have some known distance to an object but you don't know its height, like a ladder or a tree, some building that's far away. So something to keep in mind are these two phrases. You have your angle of elevation. Basically, it is the angle up you're looking. So if you're out in a field, kind of like we have across from Georgia Ranch, and you're looking straight ahead, what you should see is the horizon. That's kind of what we're talking about with your horizontal. So if you're looking out straight ahead, what would you see? And then the angle is how much you have to lift your head to look up at whatever your object is. So that is your elevation. So you're elevating your head, looking up something that's high. Now your angle of depression is the opposite. So if you think of like somebody's depressed, they're feeling low, they're looking, your angle of depression is something that is below you. So we have our horizontal line and you are looking downwards by some amount. All right, everyone. So now let's talk about the actual steps for solving these problems. Now, the best thing to do is start off by giving yourself a triangle. It doesn't have to be perfect or match up to the one in the problem. You just need to draw a triangle. This is for you to label and help figure out what you need to do. Once you have your triangle drawn, make sure it's a 90-degree angle. Again, it doesn't have to be perfect, but just label it with that box. You are going to then label what sides you have. So let's say this angle here is our given theta. And then we have our adjacent, and we have our adjacent side, we have our opposite side, and we have our hypotenuse. Now, if let's say we know our adjacent side and it's some value x, and we need to know the y, our opposite side y, then by labeling that, we can quickly look at our SOHCAHTOA, so SOHCAHTOA, and know what we need to do. So we have our adjacent and our opposite. So looking at SOHCAHTOA, we have our adjacent and our opposite and our adjacent for our t. T is for tangent. So we need to plug in our tangent of theta. And remember that the second two letters of SOHCAHTOA are the ratio. So we have for sine, opposite over hypotenuse, then adjacent over hypotenuse for ka, and TOA we have opposite over adjacent. So we have our opposite over our adjacent. Now we're solving for our opposite, so to solve for our opposite, we will multiply both sides by a, giving us whatever a is times tangent of theta is equal to our opposite. Now, we know what our a and our theta is, so we can plug that in. We said it's x tan, and let's go ahead and say this is 20 degrees. So 20 degrees, and we could solve for our y. Now we're going to be doing that over and over again, as you'll see. So here we have our first example. It tells us that we are on foot 20 meters away from our tower. So looking at this triangle that it gives us, it is going to be 20 meters from the tower to our left to wherever we are over here to the right. And it is telling us we have an angle of elevation. Remember that vocabulary word, we are looking up by 40 degrees to the top of the tower. Now, we need to figure out how to find the height. So, our tower, I'm going to label as h for our height. So we have an angle, we know the side that's adjacent to that angle, and we're looking for its opposite, which means we have our tangent of theta is equal to our opposite over our adjacent. We need to solve for the opposite side, so I'm going to rearrange this to be our adjacent side times our tangent of theta is equal to the opposite. So our adjacent is 20 meters. Our tangent is for 40 degrees. And our opposite side is our height. Now we have our numbers plugged in. I'm going to go ahead and plug it into a calculator. If you don't know how, you can refer to the last video for page 83, where I go over how at the beginning. Now make sure you are plugging in this degree symbol here, otherwise you're going to be finding the tangent of 40 radians, not the tangent of 40 degrees. So we have, when you plug into your calculator, you're going to get a result of h is roughly equal to 16.781 as your, and it's going to be in meters for your height. All right, so now we have a new problem. We are looking for the angle of depression for somebody at the top of their tower looking down at a boat that is 50 meters away. So if I draw a little guy up here, he's looking straight outwards, and the angle down towards that boat, the angle of depression is 25 degrees. Now we have this parallel line here for our horizontal from our guy, but we also have another line here that is parallel to it, that is the distance from our boat. So it is 50 meters. If you remember from geometry, we have a line that is crossing two parallel lines. So this angle, our 25 degrees, is going to be the same as this one here, 25 degrees. And it is asking us to find the height of our boat. I'm going to label that h as it asks in the question. So let's try to solve for it. So we have our angle, its adjacent side, and we're looking for the opposite. We're going to use tangent again. So we have tangent of theta is equal to our opposite over our adjacent. I'm going to solve for my opposite, so I'll multiply both sides by our adjacent, giving me a times tangent of theta is equal to our opposite. I'm going to replace the values, giving me 50 meters times our tangent of 25 degrees is equal to our height. When you plug into your calculator, make sure, again, you have your degree symbol in there with your 25. Otherwise, your answer will be wrong. So what we find is our height is going to come out to be 23.315 meters. So that is the final answer. So those two problems were with just one triangle. Now we're going to look at two. Once again, you're going to draw your triangles and label it. You need to identify what you need to solve for, and then solve for it giving whatever the answer is. So here we have an example with two buildings, and we need to find the height of both. I'm going to go ahead and label this building 1 and building 2. I need to find the height of both, and we are given the angles from the smaller building, or building 1, up, and an angle of depression downwards. So if we look at these two triangles, we have this line here and this line here. These two are parallel, and given that these two towers, they're going to be straight up, they're going to be the same distance. So this is also going to be 18 meters. Now I'm going to break this down into two separate triangles. I have my first one, it's going to be the angle of depression. It's 53 degrees down. I just said that this line here is going to be 18 meters. And I need to find this height over here. So this height is going to be the same as the height of our building for building 1. So I'm going to label it as H1. And now let's set up our other triangle. So I have this triangle here. It is an angle of elevation of 44 degrees. And once again, this line here is going to be 18 meters. So when you plug it in, or not yet, so we need to, using our angle, the adjacent side, find the opposite. So just like before, we have our tangent of theta is equal to our opposite over adjacent. We know it goes to adjacent tan theta is equal to opposite, so I'm just going to go ahead and plug in the values. So we have our distance 18 meters times our tangent of 53 degrees, and that is going to equal height 1. So height 1, after you plug it into the calculator, is equal to 23.887 meters. I don't have enough room to write the meters. And then we do something similar over here. So I'm going to go ahead and write H2. So H2 on this triangle is the opposite of our angle given, and we are given the adjacent. So once again, we're going to use our tangent of theta is equal to opposite over adjacent. So we get the adjacent times tangent of theta is equal to our opposite, which I'm going to rewrite as 18 meters times our tangent of 44 degrees is equal to H2. So H2 is 17.3 0.82. Now, H1 corresponds to the height of our first building, but H2 does not tell us how high building 2 is. It only tells us how much higher building 2 is than building 1. So if we wanted to know how tall building 2 is, we need to add H1 and H2. So H1 and H2 are going to come out to be 41.269 meters. So if you write a final statement, you would say building 1 is 23.887 meters, and building 2 is 41.269 meters. And that is your final answer for example 1. Now we have another setup. We have two stacked triangles, kind of like we had before, and it's asking us to find AB. Now before we had our right angle where D is here, but now it's at B. So our right angle is at B. In order to find the length of AB, what we can just do is add these two angles together. When we do, it becomes 50 degrees. So we have a new triangle with an angle of 50 degrees, and its adjacent side is 120 meters. We are looking for the opposite side, the line AB. Looking at SOHCAHTOA again, we once again find we need to use tangent of theta is equal to our opposite over adjacent. We arrange this, we get A times tangent of theta is equal to our opposite. In this case, our adjacent is 120 meters. We are multiplying it by our tangent of 50 degrees, and that tells us what our line AB is. Plugging it all in, we find that AB is equal to roughly 143.010 meters. And that's your final answer. All right, that is it. So just as a reminder, for pre-AP kids, you do not get a calculator. You need to know how to do it by hand, but you will be given much easier values to use on your test. My academic kids, you will be able to use a calculator and you'll get questions similar to these. That is it. Have a good rest of your day.